Let's see the Leetcode problem number 82. Remove duplicates from sorted list 2. In this problem, we have given a linked list that is sorted, and we have to return the linked list. In that list, we have which has only the distinct elements from the original list. That is, we have to remove all the duplicate elements and return the list with the original elements. Let's see how to solve this. For this, I have taken a linked list that contains those elements. Here the duplicate elements are 1 and 3. We have to remove these duplicate elements and we have to return the linked list that contains only the distinct elements from the original list. The distinct elements are 2 and 4. We have to return this. This is the answer. For this, I am inserting a node called dummy before the head node and place the previous pointer here, and also placing a pointer start and end here. And I am also keeping a variable count to increment. And I place start and end here. Now I will compare whether start and end are equal. Absolutely it is equal, and I will increment count. Initially count is 0. Now after incrementing it becomes 1. And now start and end are equal. So increment count and move end to the next pointer. Again compare whether they are equal. Yes. Now increment count to 2. And again move the end to the next position and again check whether start and end are equal. No. At this point we can stop moving end. We have to move the end pointer until start and end are equal, and we have to increment count until they are equal. Okay, this is the point here. Why we are doing this is we are counting how many duplicate elements are here. When this start and end value, we have to compare these values, not the nodes. Keep in mind, because when you compare nodes, it compares the reference. Okay, that will always not equal. You have to compare the values in that node. Until the values are equal, I am incrementing count. If C is 1, no, it's not duplicate. This one only have, and the next other element is found means count is still 1. If count is greater than 1 means there is duplicate. So what I do is I will place the pointer previous. I will place the pointer previous next to end. That is p dot next is pointing towards end. Now this pointer is pointing towards this. At this point we are removing these nodes. And next what we do is we have to increment start, right? And I will move start to the position of end. End will it at its position. Sorry. End is at its position, and I will move start here, and I again make C2 0. Okay, and again I am check whether start and end are equal. Yes, 1. I will move end to here. Whether start and end are equal? No. So stop here. I am seeing count is 1, so no duplicate. Hence we have to, now the previous is this 2. So I will move the previous to the position of start. Okay, I will move the previous to the position of start. Previous is moved from here to here. And then moving start to the position of end. And again comparing, yes, they are equal. Start and end are equal. Start and end values are equal. So incrementing 0 to 1. And again moving end. And again checking whether start and end are equal. Yes, again incrementing 2. And then again moving end. Whether start and end are equal? No. So stop here. Check count. Yes, count is greater than 1. Hence duplicate present. Hence we have to move the previous, point the previous to the end. Hence these nodes are removed. And then move start to the position of end. And again we are going to check. When we check and move the end to the null, the while I will keep a condition until we have to move the end until null. We have enter null, so stop here. Hence we have got the result, and we have to return dummy dot next. So we will get 2 4. This is the answer. Let's see the code we have implemented here. We have to move until end. We have keeping the count, and then until start value and end value are equal, we are incrementing count and moving end. When c is greater than 1, we are moving the previous pointer to the end position. That is, we are eliminating the duplicates. And if we are eliminating the duplicates, if we are not eliminating the duplicates, then we have to move the previous. If we are eliminating the duplicates, the previous is same, so we don't need to move. And we have to move start to the position of end, and again repeat. This will continues until end reaches null.